Hi, my name is Neha Monisha, and today I'm gonna talk about Physics 2212 Lab 1 called the charge tape. The main purpose of this lab is to observe the interaction between two clear charged tapes and their surrounding, observe how the charged tape induces charge on otherwise neutral objects in the surrounding, and determine approximately how much excess charge is on one piece of clear tape. The fundamental physics principles we used in this experiment is F is equals to ma, which is the Newton's second law of motion, and for our case, a is equals to acceleration due to free fall. We also use Coulomb's law, F is equals to k q1 q2 by r square, and F is equals to E cube, where E is equals to electric field and Q is charge. The main results that we got from this experiment is both the tapes were positively charged, they repelled each other since they had the same charge, and they would still repel each other if they were negatively charged. They attract a neutral object, in my case it was my hand, as it induces dipole moment, and it attracts a negatively charged pen, a pen that we charge by rubbing it against our hair. As we can see in the pictures below that they clearly repel each other and the charged tape attracts a negatively charged pen. The main procedure of this experiment is to stick a clear tape about 8 inches to a table and another tape of the same size on top of it and marking it with a U. We create two pieces of charged tape by ripping the top one off the bottom tape. We determine the charge on the U tape by moving it closer to various objects, such as hands, negatively charged pen, and other U tapes. We hold the first U tape below the second one and measure the distance between them as they repel each other. And we use this distance to calculate the electric force and the charge. As we saw in our results that both the tapes became charged and they obtained positive charges. Due to both tapes being positively charged, they repelled each other, thus pushing the B tape upwards. We calculated to see that the charge on each tape was 1.401 into 10 to the power minus 8 coulombs, and the tapes were deficient of 8.754 into 10 to the power 10 electrons. The system includes both the tapes and the surrounding includes everything else that was present in the room. The data and calculation, as we can clearly see here, Fg is equals to mg, which is force due to gravity. We calculated it to find out 1.962 into 10 to the power minus 3 newtons. As we know that both the forces balance each other, Fe is equals to Fg, which is also 1.962 into 10 to the power minus 3 newtons. We know the formula of Fe as k q1 q2 by r square, which we can use to find the charge, which is 1.401 into 10 to the power minus 8 coulombs. We know the charge of one electron is 1.6 into 10 to the power minus 19 coulombs, which we can use to find out the number of electrons present on the charged tape. We use the area of an atom and the area of tape to find out the number of atoms present on the tape. Then we find the ratio of excess electrons to atoms, which is 2.156 into 10 to the power minus 7. Here is a diagram of the whole system, and we used where we assumed the positively charged tape as a point charge. We saw that the length of the tape is 8 inches, the width of the tape is 2 centimeters, the distance between the tapes were roughly 0.03 meters, and the mass of the tape was assumed to be 0.2 grams, which is 0.0002 kgs. This is a closed grip model which validates our answers and our calculations. Some common questions is, since the momentum of the tape is not changing, what can you conclude about the net y component of the force on tape P? The net y component is 0 since the forces are balanced. What objects in the surrounding exert mainly vertical forces on the floating portion of the tape P? We know that the earth gives gravitational force and the tape A gives electric repulsive force. Some assumptions that we made for this experiment: that air resistance is negligible, each tape was treated as point charge, and each tape that was used had the same amount of charge distributed evenly throughout the tape. Some sources of error that we could get in this experiment is Charges of tape may not have been equal in magnitude. Surrounding environment may have affected the experiment, such as humidity in the room or my own hand handling the tapes. Calculation discrepancies due to the rounding of many figures has a lot of values that were rounded to 3 decimal points. Error while taking measurements of the length of separation due to parallax error. Some additional questions is, what if the electrons had positive charge and the protons had negative charge? It would not have done anything since the charges would be same, just the signs would be swapped. And it is important to handle the charged tapes as little as possible as we could earth them.